Hey guys, Mr. Milton here. Welcome back to my YouTube channel. At the end of this video, you should be able to identify the degree of rotation of a figure, and you should be able to rotate a figure about the origin. Okay, so we're dealing with rotations today, and a rotation is an isometry. Okay, remember that just means that after we're done with this transformation, it doesn't change our figure. Our figure is congruent to its original, its pre-image. Okay. Okay. But rotation is an isometry that turns a figure around the center a certain number of degrees. Okay. Therefore, in a rotation, you need to know that the center of rotation, a point, you need to know the angle of rotation and the orientation of the rotation. So it can be clockwise or counterclockwise. Okay. And kind of contrary to your natural tendencies, unless stated otherwise, rotations are always counterclockwise. So unless otherwise stated, we'll go counterclockwise. So that's the opposite of how an analog clock would go. Alright, so we're going to use this regular pentagon below to answer the questions that follow. Okay, for this, we're going to use point O as the center of rotation. Okay, now this question says, if I map A to F, what is the angle of rotation? Okay, so if we move from A, if we're rotating around the center, A to F, what is our angle of rotation? And we're going counterclockwise, so we're going this way, again counterclockwise. And so this is a regular pentagon, and so our angle of rotation would be 72 degrees. Okay, and we can find that out because 360 would be the whole thing, would take us back to the beginning. Regular pentagon will have 5 evenly spaced, so that would give us 72 degrees. Okay. Will rotations always have this degree of rotation? And the answer is no. Okay, this is a pentagon, so that's why we have 72. A regular pentagon, that's why we have 72. In different shapes, and non-regular pentagons, they'll be different. Okay. So regular. The number of degrees between the vertices is the same. In this case, it's 72 degrees. If we were dealing with a regular octagon, again, octagon has 8 sides, so we do 360 over 8, which gives us 45 degrees. Okay, all right, now it says find the image of A when the figure is rotated clockwise 144 degrees. Okay, so you can look at these sides if you like to, and I'll just highlight the side if that's easier to visualize. Looking at a line and seeing how it would move. Okay, so we have point A rotating 144 degrees around point O. So if we move it here, we'd have a P that's only 72 degrees. Move it here one more time, and then that would be 144 degrees. So then we'd have it here. Okay, so the image of point A would be at point K. Okay, find the image of F when the figure is rotated about rotated 216 degrees about point O. Remember, unless it's told otherwise, we're going counterclockwise, so we go, that's 72, that's 144, and then one more would be 1, 2, 3, one more would be did I do that right? Oh, sorry, I started at point A and that messes me up. Sorry, let's do that again. Image of F. Okay, so from here we got 72, 144, another one, there we go, P, 216. All right, almost overlooked that. Kind of jumped from line to line there. All right, so now it says describe the rotation that would map K to W. So we're going from K to W, and so we could go 72 degrees counterclockwise. That's clockwise, sorry. 72 degrees clockwise. That's how the clock would move. Okay. Or, to go from K to W, we could go here, 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 here. We do that 1, 2, 3, 4 times, so 72 times 4, which would give us 288. Counterclockwise. Okay, and it's important to make sure that we note which direction we're going. All right. Okay, next question, it says, what is the image of PK when the figure is rotated 72 degrees about point O? Oh, here we go. So PK, this point, this whole line, sorry, we're going to rotate it 72 degrees, and again, we're going to go counterclockwise, and so we rotate it 72 degrees, and we should see that this line becomes this line. So it becomes AP. Okay, what is the image of W when the figure is rotated 360 degrees around point O? 360. That's just a full spin, so if we go 360 either way, doesn't matter. We're going to end up back at point W. All right. Flipping to the back, we are going to look at rotating in a coordinate plane. Okay, this can be a little tricky, so make sure you're paying attention. Okay, so we're going to rotate this given point 90 degrees about the origin, and just rotating a point out in space kind of can be a little difficult. So what can be helpful is if you draw a line to the origin, okay, because that's where we're rotating it from. Okay, we're going to draw a line to the origin, and then we're going to use that line to help us rotate. Okay, if I draw a line from the point to the origin and another line from the resulting point to the origin, the two lines would be perpendicular, and it's going to be perpendicular because we're rotating at 90 degrees, and so we'll create a 90-degree angle. Okay, and so what we know about the slopes of perpendicular lines is that they are opposite and reciprocals. Okay, of one another. Okay, and we should know that from algebra and from some stuff we've done this year as well. And so we can use this idea to find the coordinates of the resulting point after a 90-degree rotation. Okay, so we need to find the slope of the line from the given point to the origin, and that slope, rise over run, goes 1, 2, 3, 4, 5, -5, 1, 2, 3, -5/3. All right. And now we are going to find the slope of our new line. Like we said, our new line is going to be opposite reciprocal. So opposite means it'll be positive. Reciprocal means that we'll flip the numerator and the denominator. So our new line will have the slope of 3/5. So now we just have to determine which direction we need to go. Okay, because if we have that slope of 3/5, then we have two options. It could either be 1, 2, 3 over 1, 2, 3, 4, 5 here. It could be this point, or it could be, because that's +3, +5, -3, 1, 2, 3, -5, 1, 2, 3, 4, 5. This point. So these are our two options for where that resulting point is. So since nothing is stated, we are going to go counterclockwise. Since it doesn't say rotate clockwise, our default is to go counterclockwise. Okay, so the resulting coordinate, if I go counterclockwise, is here. And that point is at -5, -3. If it had stated, hey, go clockwise, or 90-degree rotation clockwise, then our resulting point would have been 5, 3. Okay, and that's it. That's our final isometry. There's one more transformation that we can talk about, and that will be dilation.